So yesterday we started our conversation on compound inequalities. We mentioned and talked about our and inequalities. So let's first look at an example of an and inequality. So we have our example negative 8 is less than or equal to negative 7 plus v, which is less than negative 3. All right. So we have our variable with some stuff around it in the center, and it goes from least to greatest. So the easier method that we learned yesterday is to get rid of all the stuff around v and take care of it as a three-part inequality. So to get rid of everything that's around v, or this negative 7, I'm going to add 7. And whatever I do to the center, I need to do to the left and to the right. So that's going to cancel out here, and I'm going to have negative 1 is less than or equal to v, which is less than 4. Now our examples also asked us to graph, so we're going to have our number line. 0 will be here, negative 1, 1, 2, 3, 4. We're going to have an filled in circle over here because it's less than or equal to. So filled in circle at negative 1. But we're going to have an open circle over here because it's just less than. And then as we learned in our and inequalities yesterday, we're going to fill in the whole space in between. All right? So these are our and inequalities. We're going to take care of it as one giant piece, and it kind of looks like a barbell in the end. But now what if we get ones that are not and? What if we get ones that are or? So let's look at an example here. It's instead going to be two separate pieces as opposed to one larger piece. So let's look at an example. So x minus 4 is greater than negative 4, or 9x is less than negative 36. So we're going to take each part in pieces. So we're just going to look at the left inequality right now. So I need to get x by itself, so I'm going to start by adding 4 on both sides. And when I do that, I get x is greater than, and negative 4 plus 4 is going to end up equaling 0. On the right-hand side, I just have 9x, so to get rid of that 9, I'm going to divide by 9 on each side and get x is less than negative 4, because a negative divided by a positive is negative. So my answer, if I asked you just to solve the inequality, is going to be x is greater than 0, or x is less than negative 4. Now, how does this look when we graph it? Well, let's look. I'm going to draw our number line. 0, 1, 2, 3, 4. Now, it says x is greater than 0. So it's going to be an empty circle. And we know that since the inequality is pointing this way, that it's going to go this way, on and on forever and always, including in the arrow. Now, x is less than negative 4, so we know it's going to be an open circle again at negative 4, and the inequality sign is pointing that way, so we're going to fill in that way. So notice an or is going to be two separate pieces. Let's look at another example. Two x plus 3 is greater than 23, or 10 minus 8x is greater than 82. Now, once I finish giving the instructions, try to pause it and see if you can solve this piece by itself and this piece by itself. So go ahead and pause and see if you can solve each inequality. All right, so let's look at the first one. 2x plus 3 is greater than 23. So it's a two-step, so we're going to do our subtraction first. and then our division second. All right, pretty easy and pretty straightforward. So x is going to be greater than 10. So I'm going to go on to another page to look at the next part. So we knew that x is greater than 10. So now let's look at the other part of our equation. And it was 10 minus 8x is greater than or equal to 32. So what I'm going to do is I'm actually going to take away 10 first. A lot of people's inclination is actually to add 8 or to add 10, but this is actually a positive 10, so we need to take away 10. So I get negative 8x is greater than, ooh, I made a mistake. This is 82. Very important that you make sure you write down your notes correct. So it's going to be 72. My mistake. All right. Next, we need to divide by a negative 8. Now, what's really important about remembering when we divide by a negative is we need to flip the inequality before we continue. So we're going to get x is less than negative 8. So now we have our two parts of our inequality. So let me go back to our blue color. And we're going to have x is greater than 10 or x is less than negative 9. So I'm going to go back to my number line. This is going to be negative 9, 0, positive 10. Now both of them are going to be actually open circles. And x is greater than 10, so it's actually going to go this way. And x is less than negative 9, so it's going to go that way. So let's look back at the two examples that we just did, just to review. So our first example, we were given this one here. X minus 4 is greater than negative 4. So we added 4 on the left and right to get x is greater than 0. On this side, we got 9x. There we go. Now that's working. 9x is less than negative 36. We're going to divide by 9 on both sides to get x is less than negative 4. So here's our giant answer here. All right? When we get to our number line, we're going to have two empty circles. All right? And x is greater than 0, so that's going to go to the right. And x is less than negative 4 is going to go to the left. Let's look at our second example. This one was a little more complicated. So we have 2x plus 3 is greater than 23, or 10 minus 8x is greater than 82. So we looked at the first piece, took away 3 from both sides to get 2x is greater than 20, and divided by 2 to get x is greater than 10. So let's go to our next page. X is greater than 10 was our first portion. Now we need to figure out the second portion. Don't make the mistake I did and write the problem down wrong, so make sure it's correct. I'm going to start by taking away 10 from both sides and then dividing by 8. When we divide by 8, it's very important that we switch the inequality. Dividing by a negative requires us to switch the inequality. So this is going to be our giant answer to our problem. Now graphing. Negative 9, 10, both of them are open circles. X is greater than 10 to the right, x is less than 9 to the left. And that's how you solve compound inequalities with OR.